Good morning. It's July 7th, and this is your daily brief in science. Here's everything you need to know. A recent study from the Institut de Neurosciences at the Universitat Autònoma de Barcelona has unveiled promising advancements in gene therapy that could change the landscape of aging research. This groundbreaking work indicates that gene therapy can significantly elevate levels of the klotho protein in mice, leading to improvements in muscle strength, bone density, and cognitive performance, effectively reversing aging effects equivalent to 70 human years. Published in the journal Molecular Therapy and led by Professor Miguel Chilon, the study demonstrates that increasing the secreted form of klotho protein, known as SKL, can extend lifespan by 15 to 20% while also enhancing physical and cognitive aging. The researchers achieved these results by using a viral vector, administered both intravenously and directly into the brain, to ensure effective delivery of the klotho protein to targeted cells. The implications of this treatment are significant. Not only did it improve muscle and bone health, but it also stimulated the formation of new neurons and enhanced immune activity in the hippocampus, suggesting potential cognitive benefits. In light of these findings, the research team has patented the use of klotho for treating cognitive deficits and has filed 3 new patents focusing on its applications for bone and muscle deficits, as well as longevity therapies. The researchers emphasize the importance of developing a viable delivery method for SKL, which could greatly enhance quality of life and pave the way for future longevity therapies. This study highlights the challenges associated with aging, such as declines in muscle and bone density that lead to increased frailty and cognitive decline, underscoring the urgent need for effective age-related therapies. Treated mice exhibited larger muscle fibers, reduced fibrosis, and improved bone quality, particularly in females, indicating a protective effect against osteoporosis. The gene therapy approach involved administering viral vectors that introduce the gene for SKL into cells, enabling them to produce the protein independently, which is crucial for the observed health benefits. A new study by physicists from Cornell University and Shanghai Jiao Tong University presents a bold prediction about the future of the universe, suggesting it may end in a big crunch in approximately 33.3 billion years. This challenges the long-held belief that the universe will continue to expand indefinitely. Currently, the universe is 13.8 billion years old, which means there are about 20 billion years left before it begins to contract, after reaching its maximum expansion in roughly 7 billion years. The study indicates that once the universe reaches its maximum size, it will eventually collapse back into a singular point. This research delves into the nature of dark energy, which makes up about 70% of the universe and is responsible for its expansion. The findings suggest that dark energy may not act as a constant force, but rather behave dynamically, potentially involving an ultralight particle known as an axion and a negative cosmological constant. According to the proposed model, the universe is expected to expand to about 69% larger than its current size before gravitational forces take over, triggering a rapid collapse. However, the researchers note that this prediction carries significant uncertainty due to limited observational data and the speculative nature of the negative cosmological constant. Despite the dramatic implications of a cosmic collapse, the timeline of 20 billion years means this is not an immediate concern, especially considering that complex life on Earth has existed for only about 600 million years. This research represents a significant advancement in cosmology, providing a specific and testable prediction about the universe's ultimate fate. Future astronomical projects may yield more precise measurements of dark energy's behavior, enabling the testing of the Big Crunch scenario and potentially confirming or refuting this model. However, the researchers emphasize that their predictions come with substantial uncertainties, and alternative scenarios, such as eternal expansion, remain possible. Researchers at the University of Sydney have made a significant advancement in understanding Parkinson's disease by identifying a faulty brain protein known as SOD1. This protein is crucial in the disease's progression, and its malfunction has been linked to the degeneration of brain cells in affected individuals. In their latest study, The research team, led by Professor K. Double, discovered that a special copper supplement significantly improved motor functions in mice exhibiting Parkinson-like symptoms. In contrast, a control group that received a placebo showed a decline in motor abilities, highlighting the potential impact of this treatment. This work builds upon earlier findings from 2017 when the team identified an abnormal form of the SOD1 protein in Parkinson's patients that contributes to brain cell damage. Over the past decade, the researchers have focused on the biological mechanisms underlying Parkinson's disease, which is the second most common neurological disorder after dementia. Currently, there is no known cure for Parkinson's disease, which results in the death of dopamine-producing brain cells, leading to debilitating symptoms such as tremors and muscle stiffness. The complexity of the disease necessitates multiple treatment interventions, similar to strategies employed for HIV. The findings suggest that targeting the malfunctioning SOD1 protein could play a pivotal role in slowing disease progression and improving treatment outcomes. The next phase of research will involve designing clinical trials aimed at this faulty protein, potentially paving the way for new therapies. Professor Double expressed optimism about the treatment's potential, noting that the significant improvements seen in treated mice could translate to effective therapies for humans. With over 150,000 individuals affected by Parkinson's disease in Australia, the urgency for effective treatments is clear. A new analysis has uncovered a striking trend in biomedical research. Approximately 14% of abstracts published in 2024 appear to have been generated with the assistance of artificial intelligence, particularly large language models. This study, conducted by researchers from the US and Germany, scrutinized over 1.5 million abstracts indexed in PubMed, identifying more than 200,000 that displayed language characteristics typical of AI-generated text. The researchers analyzed a total of 15 million biomedical abstracts to evaluate the extent of AI's influence on academic writing. They noted a significant shift in scientific vocabulary, pinpointing 454 excess words in 2024, terms that are more stylistic than content-driven. Words such as delves, showcasing, underscores, potential, findings, and critical have become increasingly common, reflecting a notable change in writing style. The analysis revealed a transition from content-heavy language, primarily nouns, to more stylistic expressions, with 66% of these excess words being verbs and 14% adjectives. This innovative method of identifying excess words has gained traction since the launch of ChatGPT in late 2022. To address potential biases, the study employed a before and after analysis of word usage patterns around ChatGPT's release, similar to techniques used in public health research. The impact of AI on scientific writing and biomedical research is unprecedented, even surpassing the influences of major global events like the COVID-19 pandemic. Interestingly, the use of AI varies by discipline, with some areas reporting up to 40% of abstracts utilizing AI, particularly in computational fields where researchers are more familiar with these tools. Since the introduction of ChatGPT, there has been a notable increase in AI-generated content online, raising concerns regarding the accuracy and integrity of research publications. However, quantifying the true impact of large language models remains difficult due to a lack of transparency from users about their reliance on AI in writing. A significant advancement in cancer treatment has emerged from the Korea Research Institute of Standards and Science. Researchers have developed a multifunctional nanomaterial known as the triple-layer nanodisk, or AUFEAUNDS, which has the potential to diagnose, treat cancer, and activate immune responses simultaneously. This innovative nanodisk consists of iron sandwiched between two layers of gold, enhancing its structural stability and treatment efficiency compared to traditional single-function nanomaterials. According to first author Dr. Lee Yoon-suk, the unique combination of gold and iron properties significantly improves cancer treatment outcomes. The nanodisk utilizes three therapeutic mechanisms: photothermal therapy, chemical dynamic therapy, and ferroptosis therapy, allowing it to effectively target various cancer cell types. Additionally, the use of magnetism enables the nanodisk to be attracted to tumor sites when a magnet is applied, improving treatment efficiency. Equipped with photoacoustic imaging capabilities, the nanodisk facilitates real-time monitoring of tumor locations and the drug delivery process. Research indicates that the optimal treatment timing occurs 6 hours after administration, allowing for precise tracking of drug accumulation at tumor sites. After treatment, the nanodisk triggers the release of danger-associated molecular patterns from dead cancer cells, which enhances the immune system's ability to recognize and respond to potential cancer recurrence. Animal studies show that the nanodisk can increase immune cell counts by up to 3 times, indicating a significant potential to improve cancer treatment outcomes. Furthermore, the nanodisk promotes an immune response by encouraging cancer cells to release substances that help the immune system identify and attack recurring cancer cells. This new nanotechnology aims to address the limitations of traditional cancer treatments, which often damage healthy tissues and lead to significant side effects. The research, supported by the Ministry of Science and ICT, was published in the February 2024 issue of the Chemical Engineering Journal. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.